Click the bell icon to get latest videos from Ekeeda.
Hello friends, in the previous lecture we have discussed about the physical properties of aldehydes and ketones, and now in this topic we are going to discuss about the reactions of aldehydes and ketones. So now in this topic we are going to discuss about the reactions of aldehydes and ketones. So reactions of aldehydes and ketones, they undergo through that is nucleophilic addition reaction, and how it occurs, let me discuss about that also. But before understanding that, we should understand that is the aldehydes and ketones, they consist of a common group that is nothing known as carbonyl group. And this is how basically the carbonyl group is the one. So talking about this carbonyl group, it consists of an oxygen atom, and obviously we understand that is the oxygen atom is the one which is more electronegative compared to that of the carbon. So that is the reason that this oxygen will acquire partially negative charge while this carbon will acquire partially positive charge. So that is the reason that is the aldehydes and ketones, they are very much polar in nature, which consist of this group. But now let us come back to the point, and the point is basically how basically aldehydes and ketones, they undergo through nucleophilic addition. So that is what I'm going to discuss about in this topic. So we already know that is whether it is an aldehyde or whether it is a ketone, it consists of a common carbonyl group. And talking about this carbon atom is the one that undergoes that is sp2 hybridized structure, and that is how basically the structure of this aldehyde or this ketone, it is nothing known as trigonal planar. So because of the hybridization of the carbon atom, that is basically sp2 hybridized, so the structure is trigonal planar. And that's the reason that is all the angle that we could see here, that is the angle between, suppose if this is an R group that has been attached over here, so therefore the angle of RCO is nothing but 120 degree, and that is what we have discussed earlier also. But what suppose if a nucleophile that gets attached to this carbonyl group? So for that, suppose a nucleophile, obviously we understand that is it is the one which is basically attracted towards the electrophile. But talking about this too, that is the carbon is the one which is basically partially positive and the oxygen is the one which is partially negative. So obviously the nucleophile will attack the carbon atom. So thereby the electron pair that we could see, or that we the electron pair that we know that is between the carbon and the oxygen, it will shift towards the oxygen and making the structure to be very much different from the earlier one. So this is a slow step that occurs where the negative charge, it completely transfers on the oxygen atom, and the structure of this will change into, so obviously that is this is the carbon atom, while this is the rest of the valency. Suppose for this I have represented here as R. This is the valency, that could be hydrogen also, or that could be that is alkyl group also, depending whether it is an aldehyde or ketone. And talking about this oxygen atom will acquire a negative charge on it. But meanwhile the nucleophile has attached the carbon which is electrophile, and that is how basically this is the nucleophile that will attack the carbon atom over here. So now talking about the structure, this structure will change from trigonal planar to tetrahedral. The reason behind that is the carbon in the aldehyde or ketone, that is undergoing through sp2 hybridization, and that's the reason that it has a specific geometry that is trigonal planar. But now because of the nucleophile that has attached the carbon atom, now the structure will be tetrahedral, and this is all because the carbon that has undergone through sp3 hybridization. And this is the structure of the alkoxide that is acting as an intermediate. So this is an alkoxide intermediate that always occurs whenever a nucleophile that attaches to the carbonyl group of aldehyde or ketone. But suppose if this reaction occurs in a solvent which consists of protons, or in an acidic medium if we say, so obviously this H plus ion, it will attach this oxygen atom which acquires a completely negative charge on it, and that is the reason that the product that we could get, it will be the one that will have a nucleophile on it. This is the R group, this is a valency that could consist of a hydrogen or alkyl group depending on aldehyde or ketone, and this is nothing but the final product that will be nothing but OH. So this is the product that we have got, and this is all because of the nucleophilic addition, and that is how basically the aldehydes and ketones, they undergo through nucleophilic addition, and that was nothing but a general reaction that occurs whenever an aldehyde and ketone is reacted with a nucleophile. So that's it. Thank you friends for watching this video. I hope you have understood this concept very clearly, and I hope I will see you next time. Till then, don't forget to subscribe to Ekeeda channel. Thank you so much.